Algebra 2 Cram, New York State Algebra 2 Regents, Common Core, Polynomials, Question 9, Binomial Expansion. Inbox me at memedicine@gmail.com to order your complete Cram sessions. Question 9, Polynomials. What is the middle term in the expansion of x plus y raised to 4? Definitely press pause if you need to, and I'll give you some time to think. While you're thinking, I'll read out the answer choices. Is it going to be 1, x squared y squared, 2, 2x squared y squared, 3, 6x squared y squared, or 4, 4x squared y squared? Okay, so before we dive directly into problem solving, we're going to take a conceptual journey. And there are a few buzzwords and notations here that alert us to exactly what it is that we need to do or how it is that we need to think of this particular question. Okay, the first buzzword is expansion. And the second notation is this expression right here. You have x plus y. Well, this is a binomial, okay? And this is because x is a monomial term by itself and y is a monomial term by itself. And they're separated by either addition or subtraction, making this collectively a binomial term raised to an exponent, okay? All right, so what's really, really wonderful is that in the world of Algebra 2, there's a formula for this type of format, or what we call expanding a power of a binomial. So we see that x plus y raised to 4 takes on this format. A plus b raised to n, where a is x, b is y, and n is equivalent to 4. Okay? So just hold tight because we're really about to dig in deep, but don't be alarmed or worried. Your understanding will be complete by the end of this cram session, okay? And for those of you who are already familiar with all the subject matter, it'll just be a really great refresher for you. So the formula for expanding a binomial is of such. It involves summation notation, or the summation from k equals 0 to n of n choose k times a raised to n minus k times b raised to k. Okay, this is also equivalent to the summation from k equals 0 to n of n factorial over k factorial times n minus k factorial times a raised to n minus k raised to times b raised to k, okay? All right, so for now, what I want you to do is not worry about all of this because each aspect is going to be explained. We're first going to start off with the factorial concept, okay? Now, the factorial of a non-negative integer, which we're going to represent with the variable n. And when I say non-negative integer, integers are all the numbers that occur either on a horizontal or vertical number line. So 0, -1, 1, 2, 3, 4, okay? But specifically, n in our situation is representing a non-negative integer, all right? So, okay, so whenever we have a factorial of a non-negative integer n, this is going to be the product of all the positive integers that are less than or equal to n, okay? So let's say, for instance, n equals 4, which it will be in our situation. We're going to expand this. So n times n minus 1, and if n is 4, n minus 1 is going to be 3, times n minus 2, that would be 2, all the way down to 2. I guess 4 is a bad example, down to 1. Okay? So n factorial, again, is going to be the product of all the positive integers that are less than or equivalent to n. Okay? And what I also want you to note is that 0 factorial is always going to be equivalent to 1. That's the value that it's been assigned in the world of mathematics. Now, let's say you have n objects. And as a conceptual example, let's say our n objects is a deck of playing cards. There's usually 52 cards, okay? And let's say that you have this brand new deck of cards in your possession, but you opt to select k of those n objects at a time. And let's say that k is 13. Let's say you choose a suit of spades. Every suit in a deck of cards always has 13 cards. Okay, so ace, spades, hearts, whatever. They all clubs, they're 13 of each suit. Okay. So this is the way you would represent that process. If your n is the deck of 52 cards, and you're choosing k, which I told you for conceptual purposes, we're going to assign a suit of cards, which is 13. And so this notation represents the number of combinations that you can get from choosing any particular 13. So this is going to tell you the different ways of selecting, 13 cards at a time, what you're going to get first, second, third, all the way up to the 13. But this quantity can also be written as this. And it's still understood as n choose k, okay? But what's really neat is that we can take this factorial concept and apply it to our combination choosing theory that we're going through here. And this is equivalent to n factorial divided by k factorial, n being our entire set, k being the number that we're selecting, times n minus k factorial. Okay, so these are all equivalent expressions. And so, all right, now we're going to tie everything together. We're going to connect this concept with our binomial expansion theory, or the binomial theorem. Okay, all right, so let's see how we can talk about this. How can I express this to you? All right, let's go back to this. We have a binomial base raised to a power of n, okay? And so we're going to use this combination notation to represent this expansion. And what I want you to know is that the expansion always starts at selecting nothing, selecting 0, okay? If we're going to associate our combination theory with our binomial expansion theory, the first situation you have is selecting 0. So this is represented by n, choose 0, or choosing nothing, times a to the n, times b to the 0. And for your binomial expansion, what I always want you to note is that for the a term, or the first term written in the binomial, you start out with the highest power of a, which is always going to be the exponent n that you're raising the entire binomial to, and you start off with the lowest power of b, which is going to be 0, obviously, okay? All right, and so as I'm writing out this expansion, there's something that I'm going to need you to understand. We're going to be dealing with a large sum. That's why we're going to go from this summation, which I'll show you in a second, to our condensed summation notation. And the first thing that I want you to know is that our selection, or k, is going to be starting at 0 rather than choosing one thing. So this means that every binomial expansion that has a base of a plus b raised to some power of n contains n plus 1 terms. The additional plus 1 comes from beginning our summation process at choosing nothing, or k equals 0, okay? All right, but let me show you what I'm talking about. So the next term in this expansion process is going to be plus n choose 1. We're choosing one thing, times a raised to n minus 1. That's the next lowest power of 1. And b times b. This is also b raised to the first power. So you can see that successive terms of a plus b is being lowered in the degree of a and raised sequentially in the degree of b. Okay. Next, we're going to have n choose c times a raised to the n minus 2 times b raised to 2. Again, the powers of a are decreasing and the powers of b are increasing as k increases. Okay, so the powers of b increases directly with k, and the powers of a are decreased by the magnitude of k. And we're going to continue and so forth, and then we're going to get all the way down to n choose n minus 2. So this is two terms right before n times a raised to 2 times b raised to n minus 2. Again, the whatever the value is of k, that's what b is going to be raised to, and whatever numerical magnitude you have that's negative, it's going to be the positive negation, or the positive amount that's being, the positive or absolute value of the amount that's being subtracted from n when we start to shift from positive numerical values to negatives. Okay, I think you know what I'm saying. I'm going to condense it and show you how it's just this, okay? Then the next term is obviously going to be n choose n minus 1 times a raised to 1, so the absolute value of the amount that's being taken away, times b raised to n minus 1, so b raised to k, okay? And last but not least, we get all the way down to n choose n. We're choosing everything in our set, times a raised to 0, which is simply 1. I'm just writing it here so you can get more clarity, times b raised to n, okay? Our value of k is now n. So again, this is getting really lengthy and really wordy, so you can see why we had to opt to condense it into summation notation. Again, a plus b to the n, a plus b to the n is equivalent to the summation beginning from k is equivalent to 0, choosing nothing all the way up to n, choosing everything, of n choose k times a to the n minus k times b raised to k, okay? But remember previously we established that n choose k is also equivalent to n factorial over k factorial times n minus k factorial. So we substitute our combination notation with factorial notation times a to the n minus k times b raised to k. Okay? All right, so yeah, that's how we basically got to this point. And early on, when we were discussing the question stem, we said that a is equivalent to x, b is equivalent to y, and n is equivalent to 4. So if we're going to use this concept down here to solve our problem, we already have 3 values taken care of. The only thing we need to do is figure out k. But remember that I said whatever n is, you're going to have n plus 1 terms. The additional plus 1 comes from the fact that our summation count is beginning at k equals 0. And since we are dealing with a 4th power, we're obviously going to have 5 terms. So the midpoint of 5 is going to be the 3rd term. But there's one more thing you have to note so that we don't go ahead and jump to conclusions saying, oh, k is 3. Since our first term occurs at k equals 0, the second term would be k equals 1, and the third term will be k equals 2, not 3. Okay, so that's where things can get a little tricky and throw people off. So we have x is equivalent to a, y is equivalent to b, n is equivalent to 4, And we just explained that for our third term, this is the first term, second term, third term. Our third term is when k is equivalent to 2. Okay? So this is basically what we're going to use to figure out the third term. And so when we substitute 4 for n, we get 4 choose 2. Remember that our third term is when k equals 2 times x, because we said that a is equivalent to x, raised to the n, again, n is equal to 4, minus 2, all right, times b, or y in this case, raised to 2. But again, instead of having a combination notation factor, we're going to substitute our n factorial notation. So we wind up with 4 factorial over 2 factorial, because again, n is equivalent to 4, k is equivalent to 2, our third term, times 4 minus 2 factorial. Again, n is equal to 4, k is equal to 2. We're focused on the third term, that's why k is equal to 2, times x squared, y squared. Okay? All right, so yeah, we're pretty much on a roll. And basically, if you were to go ahead and, well, 4 factorial is going to be 4 times 3 times 2 times 1. And then this is going to simplify to 2 factorial. And 2 factorial is simply 2 times 1. So 2 times 1 times 2 times 1 again is all going to be equivalent to 4. The 4 is going to cancel in the numerator with the 4 that we would eventually get in the denominator. And then you'll be left with 3 times 2 times 1, which is simply 3 times 2 is 6, times 1 is going to be 6 still. And then it leaves us with our correct answer choice being answer choice 3. Okay? So lots of love